Okay, so as we already know that this subject is the study of abstract machines or abstract or theoretical model of machines that can be used to perform computations. The first kind of machine which we are going to discuss now is called finite automata. Now finite automata are of two kinds. One is called, we will discuss two kinds of finite automata. One is deterministic finite automata, and another one which we will discuss later is called non-deterministic finite automata. A little later I will also tell you that why actually we are calling it deterministic. Now here I have written down the definition of deterministic finite automata. It is a mathematical definition. And one thing I want to add over here is that if you are new to this, this whole idea of automata theory and deterministic finite automata and all these things, initially to begin with you may find it a little difficult to get comfortable with these ideas or to feel like okay, things are easily coming to you. But with some passage of time and a little bit of practice, you will find it easy. You will find that okay, now I am getting things, now I am understanding what it means. So give it some time and some practice and little bit of patience. It will require some patience, especially in the beginning. Once you have understood what is DFA, it is also short formed as DFA, D for deterministic, F for finite and A for automata. Once you have understood it, then rest of things will start coming easy to you. So let me define what it is. It is defined using 5 tuples. Okay, 5 tuples. So we have 5 things over here. I have also written it. M stands for machine. Okay, so this is, I have already told you that these are abstract machines or theoretical models. So this machine which we call as finite automata, I am representing it with symbol M. You can use any symbol. So this is defined by a particular DFA is defined using these 5 tuples, these 5 concepts, 5 aspects. So the first one which I have represented using capital Q, these are popular notations. In some books or some textbooks you may find a little bit different notations, but these are the popular ones. Q, capital Q. Capital Q is used to represent a finite set of states. Now one thing important over here is finite, the word finite. I have already told you that when we try to find a method to find how to determine whether a given string is a member of a language which is infinite. How to find that whether a given string is a member of a set having infinite number of elements. To do that we have to come up with a method, a technique that has finite number of steps. So, in trying to come up with that, the first thing we encounter which is finite in some sense, the first thing we are going to talk about which is finite in some sense is this set of states. Now, even though I have not shown you any DFA till now, but what do you think we mean by the word state? What is the general meaning of the word state? State is like you can say like something is in solid state, like water. You can say water is in solid state. So it is that situation which is in it. It is the state which is with the form, the current situation and position, of water. What kind of form it is in. So sometimes you say the water is in solid state. Now what do? You heat it. What happens? Its state changes. After a certain amount of heat, its state changes to liquid. So what is happening? Water is initially in one state, and the water, after you give it some heat, it changes to another state. So its state is changing. Similarly over here we will make some diagram, we will make some machines, abstract theoretical machines, which we will represent using a diagram which we will call as transition diagram. Okay, I hope you understand what is meant by the word transition. Basically it is closely related to how things are changing, states are changing, transiting. Okay, so a diagram that represents transition, that is representing change. So we will make a diagram using this finite set of states. This is the first finite thing we are coming across, a finite set of states. And these finite set of states, there can be any number of states. That number of states will depend on your problem, what problem you are trying to solve, what problem you are trying to compute. Depending on that problem, you will have a set of states. Those set of states will be finite, and then we will have some transitions in this state. Something will change the state of your system. Okay. For now, okay, you may might be a little confused at this state, that how is this idea of states going to determine whether a string is a member of particular language or not. So don't be worried about that. Things will get clear in slowly, times to come, as we will discuss more concepts. So next thing is sigma. This we represented by sigma. I have already told you that a language is a set of a string is a sequence of alphabet, and alphabets a sequence of symbol from a particular alphabet, and those symbols might be repeated. For example, if a alphabet is a set of symbols, for example, there is an alphabet which is this set A comma B, set of two symbols. Now a string over this alphabet could be A, B, B, A, B, B, A, right? What I mean to say, that these symbols could be repeated. Any particular sequence, any specific sequence is a string. This is one string, this could be another string, this is another sequence, this is another sequence, right? So what is sigma? This thing, this alphabet thing, this, instead of writing the word alphabet everywhere, every time we want to talk about this set, we use this symbol sigma. Sigma is used to represent alphabet, I mean this set, okay, the set of alphabets. So sigma is a finite. Now remember here, another finite thing we are talking about, the first finite thing we discussed was the number of states. Now another thing which is finite is the set of alphabets. It is a finite set, okay. Now having discussed these two things, this I will discuss in last. What is this? Let us come to this one. This is called Q naught, and here it is saying that Q naught belongs to Q. Q is a set of finite states. So it is one of the states, one single specific state in this set, and it is called as initial state, okay. Now very obviously you could think, when you want to start something, you start from somewhere. Everything starts from somewhere. Something is the starting point, right? So when you are trying to make a machine, you determine that where things will start, the starting point, like where you will initiate the transitions, what will be the initial state. Like you say, okay, the water is in solid, you give heat, it will become liquid, you give even more heat, it will become vapor. You take some heat out, it will become again water, and then you take some heat out, it will become again solid. This sounds good. But when we are trying to develop machines, abstract machine models of computation for computer science, in those machines we try, it is important for us to have an initial state, the state at which things will start. We specify that, pinpoint that state. Okay, this is where we will start. Okay, this will be an initial state. This is the state we'll have in beginning. Okay, so there is an initial state. Like when you will start doing things, whatever we will do with DFA, I have not yet told you that how we are going to, what kind of operations we are performing, and how we are going to check out that whether a string is a member of a language or not. That I have not yet told you. But whenever in short while, short time to come, I will tell you. But whenever I will tell you, whatever I will tell you, that procedure will start with a particular state. and that particular state is Q naught. We'll always pinpoint that state, and depending on our problem, the computational problem which we are trying to talk about, this state will differ. You know, the number of states will differ problem to problem. The finite sets of alphabet may differ from problem to problem. Your initial state will differ from problem to problem, but for a particular language, you know, if you are trying to make a DFA, Deterministic Finite Automata, for a particular language, that for a particular language it will tell you that whether any string is a member of that language or not. For that particular language, you will have one specific pinpointed Q naught, that is the initial state. Now, we have one more thing, it is called final state. Now, there's one for those who are beginners, there's this one little thing you should remember very carefully, because you might get confused with this, or not confused, but you might forget it. Remember, Q naught is a single specific state that belongs to Q, whereas F, which is the set of final state, is a subset of Q, right? It is a subset of Q. Now, any number of states of Q could be final states. If there are 3 states in Q, like this is a finite set of states, suppose there are 3 states in Q, one we will call as Q1, another we may call as Q2, and third one let's call it as Q3. Now, any subset of this could be final state. One of it could be final state, 2 of it could be final state, or all 3 could be final state. Even if none of them is a final state, it is still correct as per the definition of a DFA. So, any subset of this set Q, and remember it has to be a subset of this set Q, any state which is not in this set will neither be initial state and will nor be final states. Initial state, which is a single state, should also be one of this state, one of these states, that is the set of states, and the final set of final states will also be a subset of this set Q, right? So, we have a final state. Now, what is a final state? Final state is a state where you want to reach, where you are supposed to reach if your string is a member of that particular language. That's how it determines. You perform transitions. I have yet not told you how to perform transitions, but let's suppose that somehow we are transiting from one state to another. Somehow we are making change from one state to another, and while we are making change, we need to end up, remember, end up at a final state. And if we end up at a final state, we will say that okay, now this string is accepted, this string is a part of this language, is a member of this set. And if it doesn't end up at final state, we will say no, rejected. Now, how we will make the transitions, what are the rules involved with transitions and other final details, we will discuss now. So, I have not discussed this. This is called as transition function. Transition function, what is say that Q and sigma, you use these two things, this Q and the sigma. Sigma is a finite set of symbols called alphabet. So, you take a state Q, right, any particular state Q, one of these states, like this is a set, any of these state Q, and you take one of these input symbol, any input symbol. So, from any state, on any input symbol, there is a transition. Like water is solid, you give heat as input, there is transition, it becomes liquid. Water is liquid, you give heat as input, what happens? It becomes vapor. Water is liquid, you take heat out, or in other words I can say you give coldness as an input, right? So, what happens? It converts into solid. Okay. So, I have drawn a diagram over here, and it may seem kind of foreign to you in the beginning, but with time you will get familiar with it. This is a state. What we do, we represent states using these circles. These are some rules in our diagram. How do we represent states? We represent states using these circles, and we write the name of that state. To every state we have given a name, and we write within the circle the name of that state. And how we transit from one state to another, like in this diagram I have got two states. One state I call it Q naught, another state I call it Q1. I have taken two names. So how we transit? We write transition rules on this arrow. What this mean? That if you are in a state Q0 and you get an input, suppose our sigma over here is this, right? And our Q over here is this set Q0 and Q1. Our initial state Q0 is this state Q0 and our set of final state is this state Q1. Okay. So we have two states. Now what is happening? Q0, when given an input A, we know what we write above these lines, this arrow is that, you remember this arrow is pointed this way, you remember, you look at this sign, this point, okay, this arrow is pointed this way, so it means Q0 when given an input A will go to Q1, right. Suppose if this B would not have been here, it would have meant that Q0 when given an input A will go to Q1. And suppose if I write a B over here, this means that if you are in a state Q0 and you receive an input B, just as when water is solid and you receive as input heat, your state is Q0, you receive as input B. What you do? You move from state Q0 to Q1. Now suppose I want to say that, okay, if you are in a state Q0 and whether if you receive input A, then move from Q0 to Q1, and also if you receive input B, then also you move from Q0 to Q1. That thing I can write it like this. This means that in both the cases, when input is A and when input is B, you are in Q0, you get input A, you go to Q1. You are in Q0, you get input B, you go to Q1. For now, all I am doing is explaining you the transition diagram, what the symbols in the diagram means, how this diagram is used to check that whether a string is a member of the language. That is something I am yet to tell you. So how do we specify initial state in our diagram? I have told you there is one initial state we will start doing things. We will put an arrow like this, an incoming arrow. It is not coming from anywhere. Right, it is not coming from any other state, it is just a simple incoming arrow towards the state. This arrow, right, this thing, remember this carefully, this arrow is used to specify your initial state. Now, how we specify final state in our diagram? We specify final state in diagram using this double circle. So, if any state is like this, double circle, and then here we have a name of a state. Any name, you could use any name. I am using Q0, Q1, QF. Such states are final state. In this diagram, I am having only one final state, but it is not necessary. You may have any number of final states, but there should be one initial state. That is necessary. Okay. Now, I have one self loop over here. You can also use self loop. What it means that if you are in Q0, you get an input A, you remain in Q0, okay. That may happen like suppose if you are in a country X, you apply for visa, it gets rejected, you remain in that country, you don't go out, right. So similarly, you are in a state Q1, you get an input A, you remain in Q1. You are in a state Q1, you get input B, you again remain in Q1. So this is what this particular diagram means. Problem to problem, your question to question, this diagram may differ, the transitions may differ. Okay, so now let me tell you how we will determine using this diagram that whether a particular string is a member of a set that is representing a particular language, or whether this particular string is a part of a particular language. How we will do that? Now, I have already told you when I was discussing final states, what we need to do, we need to end up at final state. So, if a string end up at final state in this diagram, we will say that that string is being accepted by this machine. If a string is not getting ended up in a final state, we will say that that string is not being accepted by this machine. Let's have this string A, A, B, B. Now look carefully that how we will check. We start at initial state Q0. So when we will start, to begin with, we will assume that we are here. So where are we? We are here. So we are at Q0. To begin with, we are already at Q0. Right? Now we will take each character. Okay? Each character sequentially as input one by one and see where we will go. So first we will do what we will do, we will take A as input. We will take A as input because A is first character. So we are in Q0, we are given as an input the character A. What will happen? If you are in Q0, you get A, you move to Q1. What does A comma B means? It means that if you are in Q0, you either you get A, then also you move to Q1. Or if you get B, then also you get any one of them, you move to Q1. So you are in Q0. Here you are getting A because we are checking for this string. Where we go? We go to Q1. So our current state is Q1. Now we are at Q1. Now while we are at Q1, we are already at final state, but there are characters left in this string. Okay. So at this point we will not assume that the string has been accepted. We will only assume, listen to it carefully, we will only assume that a string has been accepted when, after reading the last character of the string as input, or when by inputting the last character of the string we land up at a final state. Okay. Getting a final state in the middle, somewhere in the middle, while we are traversing, while we are checking for transitions, does not make your string get accepted. Your string is accepted only when, by reading the last character of the string, you reach the final state, any of the final states. Now you are in Q1, which is already a final state, but will not assume that the string is accepted because we still have characters to read. Now what we'll do? We'll read the next character A. We are already in Q1. If we are Q1, we get A. Where we'll go? We'll go to Q1. Simple. Again we will see, if you are in Q1, you get B. Where you will go? You will go to again Q1. If you are in Q1, you again get B. Where you will go? You will get Q1. So as we can see that this string is getting accepted. Right? Now if you look carefully at this particular diagram, you will notice that it will accept all the strings whose length is anything between 1 to infinity over alphabet A and B. Right? You have anything over alphabet A and B whose length is either 1, that length 1 means it is having at least one character. So if you have just one character A, it will get accepted. If you have just one character B, it will get accepted. So anything having length 1 to infinity over alphabet A and B will get accepted by this string. So I hope you understand the basics of, at this stage you are not expected to know the details of everything. You might be having a little questions, but what you are expected to know or expected to have understood at this stage, that what do we mean by state? What do we mean by this sigma, which is the set of alphabets? What do we mean by transition function, the initial state and final state? And when you have a set of alphabets sigma like A comma B, then you can use only these alphabets in your transition diagram. Okay, this is what you are expected to know till this stage. Obviously there is yet to explore.